Okay, question 8c, final question on this paper. Quite a lot to take in on this question. We're told the elements that are contained within the complex, the compound, at the start of the question. We're told that they're cobalt, nitrogen, hydrogen, and chlorine. So we're imagining we've probably got some type of amine with some chloride ions kicking around, and obviously with a central cobalt metal ion. That's a little bit clearer when we're told we start with an aqueous solution of cobalt chloride. We treat that with ammonia, so we can imagine we've got some sort of ligand exchange going on, followed by oxidation of the central metal cobalt 2+. So presumably we're taking the cobalt 2+ and we're making a cobalt 3+ ion of some variety. So we've probably got a cobalt 3+ with some formation of ammonias around the outside, probably 6 of those. Plus we've got some chloride ions kicking around, and that's what the question is ultimately getting us to work out. It's asking us to work out the mole ratio of chloride ions to the cobalt ions within Z. So first part of the question is to establish how many cobalt ions we have. And we're told at the start of the question that we had 50 centimeters cubed of a specific concentration. And so a simple mv over 1,000 equation at the beginning of this gives us 50 multiplied by 0.203 divided by 1,000. That generates us a value of 0.01015 moles. That's for the cobalt 2+ ions. We're assuming that that's become cobalt 3+ at the end of the day, but the ratio of the 2+ to 3+ is going to be the same value. We've then got to establish how many chloride ions we've got, and we've got within the question 4.22 grams of the resultant silver chloride. So if we take silver chloride, we know its formula is AgCl, and we are told we have 4.22 grams. If we divide that by the RFM of silver chloride, which is 143.4, we generate 0.0294 moles of chloride ions. So a direct comparison then of these two values will lead us to the ratio of cobalt ions, cobalt 2+, to chloride ions. Obviously, we're imagining the final formula of the complex will be a cobalt 3+ ion, but cobalt 2+ to the chloride minus ions is a 0.01015 to 0.0294, which when you churn these numbers up gives you a 1 to 2.9 ratio. Mark scheme is quite specific and doesn't allow you to round that to 1 to 3. The question actually gives you a bit of a clue as to not rounding that to 3, because it's asking you a supplementary question as to why is that value not 3. So we can establish that this value is actually now slightly less than it should be, because in the formula of the compound that we're now expecting, we're expecting there to be this cobalt hexaamine 3+ ion, which is probably, we would imagine, surrounded by 3 chloride ions counter-ioning the 3+ charge on the cobalt. But obviously we can now establish that only 2.9 are there and not the actual 3. So perhaps why are we establishing that? Well, a couple of things. Possibly the cobalt 2+ hasn't actually undergone full oxidation. So maybe the oxidation was the issue and we haven't actually got entirely 3+. That would therefore affect the value of the 0.1015 value. And also chloride ion is a ligand. And so some of the ligand may have acted as a ligand, should I say, and actually start as a substitute into it. And that will again play with your ratio.